Hey guys, here is lesson 1.2, functions and graphs. All right, first thing not on the notes, but I want to bring up, remember we have independent and dependent variables. Our independent variables are usually like x, and then our dependent variables are like y, because that dependent variable depends on the x put into it, okay? All right, so a couple vocab words for you. First one, domain and range. Domain is your inputs or your x variable. So domain is your value of x's. Range is your outputs, or our range is our y variable, or talking about f of x. Usually when we talk about range, we're talking about how high and low it goes. Okay? A function is a rule where each input has only one output. Super important. For functions, input has to have one output. Okay? So our x matches exactly to one y. So y, or f of x, they're the same, is a function of x. Okay, so one y value to an x value. Domain and range are often written in intervals, and that's what we're gonna work on now. Okay. All right, notations to remember. Okay. Right here, this is greater than or less than. It's also denoted when graphing with an open circle, or it is notated with parentheses. Okay. Greater than or equal to or less than or equal to has a closed dot, and they are always notated by brackets. This is negative infinity, positive infinity. If you're going to write that something goes from negative infinity to positive infinity, they always have parentheses around them. Okay. And this would be the union of, or also saying this and this. Right. Reorganizing myself. So here's some examples. What we're going to do is we are going to write what this is saying. Okay, so what this one is saying is our x value. Okay, this symbol is going to be greater than or less than. We're going to the greater direction, so we're going to say greater than -1. The open arrow means we aren't including -1. The other way to write it would be a parenthesis, -1, and it's going to go on forever, so it's going to go to infinity. Infinity always has a parenthesis next to it. So these are two ways that we can write what this graph is telling us. Okay, next graph, let's look at that one. It's going to start at -1. Anything on this side is going to be greater than or equal to that -1. And as we keep going, anything on this side is going to be less than, because it's an open there. I didn't even write that right, did I? Nope. It's switched around. Yes, it is. My answers are wrong. Okay. Okay, so x is going to be either greater than or equal to -1, so reading it that way, or it's going to be less than 2. Right? The other way to write it, I kind of like the bracket and parenthesis way, because you don't have to really worry about this. What matters is that we have a -1 and we have a 2, because those are their endpoints. This side is going to have a square bracket because it includes it. This side is going to have a parentheses because it's open. Way easier. Love this. This gets confusing, obviously. All right. Identify the domain and range, and then sketch the graphs. So, we are going to think about the domain and range of these. What I might even possibly think about doing beforehand would be sketching the graphs or throwing those graphs into your calculator if you don't remember what they look like. Okay, so I'm just going to throw out my calculator, and I need 1 over x. Actually, let's just clear this out. 1 over x. Remember, your stat plot is probably on, so you want to go turn that off. You're going to want to make your window probably the standard window, which is -10, 10, -10, 10, 1 graph. Okay, so that's what our graph looks like. So, what is the domain of that? Well, it looks like, remember, the domain is our x's. So what x's? It looks like it covers all of the x's, except it looks like y is, the y-axis is an asymptote. So we could write it, I'm going to write it using parentheses and brackets, all right? So it goes from -infinity to 0. It doesn't include 0, so we're going to put a parenthesis. And then this is where I use that union U. And we start at 0, we go on to infinity. We don't include in 0, we don't include infinity. Okay? So this is how we would write the domain. Okay, and it looks like our range is the same. It goes to infinity, -infinity, but doesn't have 0. So we're going to say that our range is the exact same. -infinity, we don't include 0, so we have a parenthesis. This means we want both of these things. Okay. All right, so then I'm going to put down a sketch here. I'm just going to use my graph to make my sketch. All right. We could think of some points. So if you put a 1 here, it's going to be 1. And -1 will be a -1. If you put a 2, we're going to have 1/2. So, and just something like this. That might not be perfect, but I said sketch. Okay. If you want to get that graph first before you make the domain and range, maybe easier. All right, next one. The square root of x. It's another one we should know. We know that if you put in 0, it'll be 0. If we put in 1, it's going to be 1. If we put in a 2, it's going to be the square root of 2. So let's go to 4, because then we know it'll be 2. Okay, so it'll look something like that. Like I said, you could have thrown out your calculator, plug some points in your head so you can sketch it. Okay, so let's talk about our domain. Our domain is our x's, so our x values start at 0. On this one, though, it includes 0, so we're in a square bracket, and it's going to go forever. So we got infinity, and we close it off. That's all of our domain. Our range is our y value, so it looks like we start at 0 and go up forever. So it's going to look exactly the same. Okay. All right, next page. Graph on a calculator. Identify the domain and range. So I left a place to just throw in a sketch. The other ones are kind of assuming that you can plug in values, which you could do. Okay, so let's plug this one in. The square root of 4 minus x squared. Graph it. It is a little semicircle there. It goes up 2 over 2. So it looks like we're at 2, 2, 2, and then we'll just curve it around. Perfect. There's my sketch. So now let's figure out our domain and our range of this. So our domain, our x's, it looks like they go from -2 to +2. It includes -2, and we include +2. My range looks like we go from 0 to 2, and they're both included. So we're going to include 0, we're going to include 2. Done. See how the graph really helps us to kind of figure out where we're going to be. All right, so we're in our next one. We have x to the, remember to put that 2/3 in parentheses so it gets included. I'm going to graph it. And we have this nice little thing here. This actually isn't a v function, it's actually curving. Okay, so it looks like we got, so it looks something like this. And then it should be symmetrical. We're calling it a sketch, okay? So our domain, it looks like our domain is all x's. If you're not sure, we could zoom in on 0, 0 and make sure there isn't a hole there. It doesn't look like there is, okay? We could also do 0 to the 2/3 power, and that's 0, okay? It didn't give us an error. So our domain is going to be, just checking myself, okay? -infinity to +infinity, okay? And my range looks like we start at 0 and go up. So we include 0 to +infinity. Okay, next thing we're going to talk about is even and odd functions. So something is an even function if you plug in a -x where the x is, and you get the exact same function out. So this means it's going to be symmetric about the y-axis. So this is an example in the pink for you. Our x² equation is an even function. If you were to fold the paper from here, it would sandwich on top of itself, okay? And it would be the exact same. So it doesn't matter if we plug in a 1 or a -1, we still get the same answer. An odd function, if you plug the opposite of x in, you're going to get the opposite of the whole y, okay? Those are going to be symmetric about the origin, so they're symmetric pretty much if you twisted it 180 degrees, right? So for example, if we plug a 1 in, we get a 1. If we plug a -1 in, we'll get a -1. So it's the exact, so it's kind of like the flip. So we can test those using this information. I'll leave that up there so you can see it. Okay. So what we're going to do is we're going to test all of these. How are we going to test them? What we're going to do is we are going to plug in a negative to here to see what happens. So -1, oops, sorry, -x. Boop. So everywhere in x's, I'm going to plug in a -x. So did this one change at all? They're exactly the same. So this is going to be the one where it's exactly the same. So we're going to say that this is an even function. Okay. So we'll try this one. We'll do f of -x. So -x. So when we put a -x in here, the whole entire thing became negative. So that's going to be an odd function. if you think about it, here, I'll give you a quick little sketch here. Here's y equals x. So if you put in a 1, you get a 1. If you put in -1, you get a -1. That's why it's odd, because if you were to rotate it, it would sit on itself. This one is going to be just the x squared function, a parabola moved up 1. So it's just going to be our parabola here, which is symmetric. Okay. All right, so let's try out this one. -x. So that means we got to put a -x plus 1. Okay. If this whole thing, okay, I'm going to show you. So if it's the negative of the whole y, it would be the negative of this whole thing. Okay. So that would be -x minus 1. So are these two equal to each other? No, they're not. So it would be neither. Okay. If you graphed this one, okay, you don't need to graph them every time, I'm just showing you why. Okay, you'll see that because it moved up 1, you can't just spin them around the origin. They won't line up. So that's why this one is not going to work, and it's neither. All right, piecewise functions. So piecewise functions are when we graph chunks of our function. All right, so graph this thing. All right, so what we're going to do is we're going to start with this. I'm going to see if I can grab one of my pencils so we can do some erasing. Piecewise are better when you can erase. See if you can see it. Okay, so -x will be starting here and just going up 1 over 1, up 1 over 1. Oh, good, you can see that a little bit. We want to be less than 0, so we're going to start at 0, and it's going to be anything less than 0. Okay, so that's that first piece. The second piece says from 0 to 1, we're going to have x squared. Okay, so the x squared is, we would need 0, and it includes it, so we can fill this bubble in. Okay, and if we plug in a 1, it's going to be 1, so we're going to go here. So we're going to be kind of curved to this point. So we could check them off. Check, check. Okay, and the next one is that we're going to do the line 1, which is a straight line. Anything greater than 1. So we would have an open circle, but it was filled in already, so we can leave that alone. And we're going to just make a line on there. Okay? That's graphing our piecewise function by pieces. Okay? If you need to erase, so for example, if you needed to draw this whole thing and then erase to the point where it is, that's fine. Okay. Or keep drawing our parabola, that's fine too. It's okay that our parabola is not the perfect angle. Okay? We have an idea. All right. I'm glad to know that purple pencil works. That was awesome. All right, write the formula for the function of the graph. All right, so we are going to write our own piecewise function. So we are going to just put f of x equals, it looks like we have 2 pieces to our function. Okay. So let's do this first one. We could write our like our domain for it first. So we start at 0. We want 0 to be included, so x is going to be greater than 0. And it's going to go to 2, and we're not going to include 2. Okay. So if we start at 0, we go up 1 over 1. that's going to be a slope of 1 and a y-intercept. So here, so if we do y equals mx plus b, we are going to have a slope of 1 and we're going to have a b of 0. So this line is y equals x. So let's do our next line. It is going to go from 2, and it's going to include 2, all the way over to 4, and it includes 4 as well. So now we got to figure out the line. So let's figure out what it's. We know that its slope is up 1 over 1, so we know our slope is 1. Let's figure out our b. Down here, down here. So I'm going to draw my step, down 1 over 1. So it looks like my b would be 1, 2, so minus 2. So the equation for this one is x minus 2. And that would be my piecewise function. So take each piece a step at a time. All right, absolute value function. The absolute value function is a funny function because the absolute value function is also a piecewise function. All right, so we could see it as two pieces, this side and this side. All right, so what we're going to do is, let's start over here. Let's find our domain and our range of our absolute value function. So our domain is our x's, and it looks like we cover all of our x's. So we're going to go negative infinity to positive infinity. Our range starts at 0, goes up. So we include 0. Okay. So now let's make a rule, a piecewise rule, to create this. All right. So let's start on this side. So from when x is less than or equal to 0, okay, what are we going to do? We're going to go up 1, negative 1. Okay, it starts at 0, so we're going to do a negative 1. Okay. And then when our x is greater than or equal to 0, because they start in the same spot, they can meet at the same spot, that's okay. We just go up 1 over 1. And there's our rule for the piecewise function absolute value. Okay, so kind of interesting. All right. Draw this graph, then find the domain and range. So some things I want to remind you, okay, is this component right here tells us to go, this is it moving on the y-axis. Okay. This tells you to go up or down. In this situation, it's a negative, so we're going to go down. So pretty much we are going to go down 1. This piece right here tells you which direction to move. I'm just going to find it, make sure. Okay. Remember, this is going to go the opposite of what it's telling you. So instead of going negative, so this is going to go on the x-axis, and it's pretty much the opposite. So instead of going negative 2, we're going to go positive 2 and down 1. And that's going to be the starting corner for our absolute value function. Now, because there's nothing in front of the x or the whole thing, we just go at our v on of. I know, it's throwing a lot at us super quick. So, domain, okay, our x's, looks like it's going to cover them all. Why are we doing this? Because you're going to see these domains They're going to pop up in calculus. Okay, range. Our lowest point is at a -1. We want to include that, and it's going to then go up forever. Okay. All right, composite functions. So composite functions is when you put one function into another function as a substitute for x. So this is f of g of x, f of g of x. So when we take f, we do whatever function of f is, and we put g of x in for x. Okay, so f of g is the same saying f of g of x or f of g of x. Okay, this is all similar notation. So it says, find a formula for f of g of x if g of x is this, f of x is this, and then find what g of 2 is. Right? So let's do this first. Right? So what we're going to do is we want to take f of x, and we are going to pretend that this is pretty much this. This is what we're going to actually put in there. So I'm going to say f of x squared, and everywhere there's an x, I'm now going to put an x squared instead. Okay, that's it. This one was a super easy one. All right. If I had more x's, then I'd have to put whatever this is or all of it everywhere it's located. Okay. All right. So now it wants to know what if we have g of 2. Okay. So what we can do is we can put, instead of here, we can put this 2 I'm just making sure I tell you the right thing to do. My head started blanking for a second. Okay. So now what we would do is we would just go, because this is also equal to f of g of x. So now we're going to just go, we're going to put this. So f of g of 2 means that we're going to take this right here, because this is f of g of x, and we're going to put a 2 in for there. So 2 squared minus 7 equals 4 minus 7 equals -3. That's your answer. And then if it wants to know what this is, that's your answer. Okay. All right. Homework. Page 19, number 3 through 51, every third one. Okay. Let me know if you need something. Have a wonderful day.